Well, I guess first we'd just like to thank everyone who participated in this project. While it's a very small project, it took a pretty huge effort to actually make it happen in about a time period of about a year. So numerous organizations involved, including, as mentioned, the Downtown Alliance for New York, the Lower Manhattan Cultural Council, the Department of Transportation, the MTA, Building Department. There was a pretty long list of organizations, as well as the New Jersey Institute of Technology, our office, individuals at our office who worked diligently on it, as well as students at NJIT. Right, and here's the list of everyone that was involved. So, Best Pedestrian Route really looks at the process of construction as a liminal activity. That this threshold may be a physical space existing between the space of the construction site and the finished building. It may be a temporal zone between the conception of the project and the actual realization of the project through construction. Also, it's the space between the digital fabrication process of prefabricated components and the interpretation by contractors on the site in the installation of those prefabricated components. It also exists as the space between the graphic symbol and the representation of the project through drawing. We like to think that our work resonates within this zone, within this liminal zone, and that's what Best Pedestrian Route explores.
So Nicole's going to talk about the site, but just to briefly talk about how we got involved with this project. The Lower Manhattan Cultural Council put out an open call for entries in April 2007, so just over a year ago. And the call was for artists and architects to intervene with the many kind of construction sites that we see in Lower Manhattan. Our office actually is right at 7 Day Street, right by Century 21, so if anyone knows where that is. And so we're right in the thick of this. So the Trade Center is happening, and the Fulton Street Transit Hub is happening.
A little louder, please.
Sure. The Trade Center is happening, and the Fulton Street Transit Hub site is also happening across Fulton Street. So we really felt an immediacy with what was happening in the area and sought to try to map a series of zones where we might insert our project.
We began the project with a site mapping exercise. On April 27th, we set out to map the condition of the site, which was constantly shifting. So we took a period of a couple of hours to map those shifting boundaries. And this site diagram really shows the various kinds of construction barriers that we found on the site. So whether it was orange construction cones or jersey barriers out of concrete or green mesh fences, we represent those each here in this map, or covered scaffolding as orange zones. So we were really interested in these areas, and in order to respond to the Lower Manhattan Cultural Council's call for entries without a kind of specific site, we were looking for potential sites that we might locate our intervention. And so in doing so, we observed some of the conditions on the site, and this was one that we found that occurred quite a lot at the corner of Fulton and John Street, was that tourists and office workers were leaning against jersey barriers, and that we might actually take that lean as a temporary condition and really formalize it into the structural ribs of our proposal. The ribs also were really modular in nature, and were a kind of play on the orange stripe patterns that we found on the jersey barriers. And we used that as a way to kind of provide a modular structure to what would be a pedestrian walkway, a place for seating, potentially a place for information to be located, as well as a shading device. So this was a likely site that we attempted to identify through our site mapping. And this was then what became a possible site as we got a little bit further into the process of working with these agencies. This is actually at the corner of Day Street and Broadway, where this will be a kind of secondary entrance into the Fulton Transit Hub. There's a blue plywood barrier there that we were asked to build our generic proposal now specifically for this site. And as soon as we needed to do this, there were now specific limitations on the generic proposal that we had created for the competition. And we needed to respond in a very specific way to these things, like a traffic sign, the width of the sidewalk, the lack of any kind of structural support behind this blue fence. There's basically a 100-foot deep pit behind there. So there were a number of constraints that we were faced with. And the modular nature of the structure also allowed us to increase or decrease the length, and in this case, respond to its location at a corner where we took the shading device and pulled it out in curvature and lifted it in section to announce the corner. And so this was it installed, and it's a little bit of a cluttered image, which really speaks to the conditions downtown, but here was our specific proposal for this now more possible potential location. And this diagram actually shows the kind of generic nature of the proposal, that there would be some kind of backup template that would establish a regular geometry into which a series of plywood lattice components could be inserted, and then the rib components could be inserted into this. So we really viewed this as a highly flexible, modifiable system. And this was a view from the interior looking out for a possible site.
So as we worked a little more closely with the institutions, the DOT and MTA actually came on board, and they said, well, we're not going to let you do this unless you mock it up, and we trust that it's not going to fall on someone or something like that. So enter NJIT, where I teach, and fortunately we have a series of CNC equipment and some large-scale lab spaces that we actually used to make a mock-up. And we worked with a group of students from NJIT as well as employees from our office and Bureau Happold, consulting engineers who helped us think through the problem of cantilevering, the problem of pocketing. You can see a series of aluminum gusset plates that were all custom cut into a series of plywood ribs that Nicole just spoke about. And so this is a quick diagram of how the ribs go together. We had cantilevers in the roof of up to 11 feet. And so this was, again, something that we really needed to structurally test and mock up to make sure that the city agencies were comfortable with what we were proposing. So this is the mock-up being assembled in the fall at NJIT. And we decided that we would do 3 bays, and we picked for the Broadway and Day Street site the longest of the 3 bays. So this represents, this image shows the longest of the cantilevers that we're talking about. And so here it is going together. And really what we found was, even though the parts of the ribs that backed up into the wall were quite stable, the cantilevers were actually subject to a lot of lateral loading, and it wasn't until we actually got some sheathing on it that that we were able to satisfy the MTA and the DOT that this was a doable thing. So we went back to the site, and right as soon as this looked like a go, the DOT decided to close Broadway and took our project away from us, which was quite a harrowing couple of days there. And the MTA kind of came back and intervened and gave us our site on Broadway and John Street, which is where the project is currently installed. And so we made a series of architectural drawings that we were able to use to pull permits, as well as a series of renderings. And what was really nice is because of all the construction that's happening down there, we were able to get a very large site, a staging area just next to the Corbin building, which was purchased by the MTA and is going to be their headquarters once the Fulton Street Transit Hub is completed. Now these are a series of literal computer files that were fed into the router that cut each of these. Nicole spoke a little bit about this being a modular system that we needed to very quickly be able to customize through the software that we use to generate the geometry and just moving it across the street and flipping it so that it leans in another direction was actually something that the MTA expected us to do quite quickly, deal with facets like telephone booths and street signs and this kind of thing. So we really like to think that we worked with, we worked with the software and the fabrication equipment to really kind of test this. But one of the things that I think we've sort of come to grips with, because we do sort of practice and teach, is that the computer is actually seen kind of academically as something for formal speculation, and the computer is seen professionally as something that's a little bit more management minded. And we thought that this, as a little research project, ended up being a nice opportunity to try to sort of merge both of those seeming disparate kinds of conditions. So here are a series of NJIT students actually painting some of the final cuts.
Those arrows are still visible on the floor.
And here are a series of the ribs that were actually set up on plywood. I should say very quickly, if there's any techie people here, that there were 3 types of cuts that we actually used to fabricate this. We had profile cuts, which allowed for the shapes to be cut. We had drills for bolting, and then we had pocket cuts, which we used to basically insert the gussets into the sandwiched ribs. So here on the build day, we actually built the ribs in the staging area with a series of students, and then had to use a contracting firm to actually install it on the street because the DOT wouldn't allow us to pull a building permit ourselves. And here it is going up. This was sometime around the end of October, beginning of November. And you can see the ribs that were slotted into the lattices. We basically gave the MTA for the blue construction fence that you see behind our work a series of sheets of plywood that we had used our router to actually slot. So everything kind of went together like a jigsaw puzzle, which was actually quite nice.
Actually, these images really speak to that because we were required, because of the sidewalk permits that we were able to get, we had to get this up in 3 days maximum. So the kind of prefabricated nature of this and the precision of all of the components really allowed that to happen. So there was really a minimal amount of on-site measuring, and the contractors were able to really do it. So this represents day 1 and day 2. And we ran the camera through the night, actually, from our office above. And day 3, and someone turned the lights on in the middle of the night. Don't know who. And this is a compilation of the 3 days.
And so we'll just very quickly show you some final images of the piece installed.
I think one thing that really interested us actually in these final images, and as we've seen it in the site, is the fact that it really in many ways blends in with the construction materials themselves, at the same time differentiating itself maybe as something a little bit different. And it's neither part of the construction site nor entirely part of the sidewalk. Construction workers walk through, tourists, office workers. It's really in the in-between zone.
So we thought briefly what we do is show you a very quick animation, which I think was played here. So this represented 3 days of effort here. Thank you.